All right.
Hello.
Great. So I'm not. Yep.
Hi, welcome everyone. So welcome at our second version of the Titanic exercise. We're going to go through the exercises last time, but hopefully this time we are going to have a better quality screen, and you can follow the programming much easier. Also, we refactored the anti-exercise, so the steps are easier to follow and more straightforward to get through. So it means that a bit easier to get the takeaways and get into a structure that you can reuse in other exercises. Let me introduce Lazy Evil from the Discord. Matteo, please introduce yourself.
Yep. Can you hear me? Yep.
Yes, I can.
I guess. Yep. So I'm Matteo. I joined the Discord community. I guess at this point it's been a month ago, right? That's when we started this thing. I met Laszlo via the MLOps community on Slack. And I was really interested, so I got into machine learning a few months ago with this new role here, and I was really interested in production quality code, just trying to step away from Jupyter notebooks and the likes. So just trying to write good quality code and do data science, right, both together. And so I met Laszlo on Slack, and we started exchanging a little bit, and I was really curious about his ideas, his Substack, and everything. And this is how I guess we basically met, and now we're here. Right?
Okay, thank you for the introduction. I was just checking the feed whether it works on my phone. It seems like we are in business. And shall we start?
Sure.
So the exercise starts with a notebook. This is essentially solves the famous Titanic survival problem, which is written in pandas and scikit-learn code, splitting the training and the testing sets, extracting features, and then turning it into data that can be fed into a logistic regression. We calculate the confusion matrix, and then print these out, and also, as you can see, this is the first step. What the project do is to create this very simple functional testing, where you are in the first row you save the output of what was computed in the notebook, and the second run you are comparing it. It means that if you change your code, you are going to be able to run this test again and see if you change the behavior. And this is the core concept of refactoring, that you are changing the code but you are not changing the behavior, and therefore you can compare two runs that needs to be the same. And if you change the behavior, you can check from the tests how the tests fail and what's the difference between the two, that you are changed it in a way that you want to know. And this creates a workflow. This is very easy to set up. Maybe it's about 10-20 lines. Very easy to start with, like a quasi-test-driven development structure, because you can run tests, you get them for free, and then you can work from that point onward. And of course you can write unit tests later. So this is obviously just an introductory course for a few key topics that is enough to start working, but obviously there are a larger body of knowledge behind that, and that you can pick up and learn and make yourself even more advanced, right? So I have a Git setup as well. I set up a virtual environment. There is this make virtual environment shell script that will create you the right setup. And I started a Jupyter Notebook server as well, and run this and then save these data files. So everything is set up. I also made the first step that this is step 2, created the Titanic model Python file and shell script, so we can start running them. And the first step, what I need to do, is to take the code from this notebook and then copy paste it into the Titanic model, the Python script file. And while I'm doing, please feel free to talk about, Matteo, some extra content.
Yep. Right. So I think what you mentioned was really important, that these are really like basic starting steps, right? Like important concepts, maybe more like first principles, just a first step into good code design. And it's probably a good idea just to take it step by step in general, right? And just start simple, and then don't get too hung up on more technical details, maybe like type hinting. Unit tests maybe at the beginning is not necessarily what you need, and etc. So I think, yeah, what we're going to show is mostly those first steps. I think that are really important. At least these helped me a lot, also in the way of thinking about how to design, how to organize the code.
Yes. I was thinking about, I had a conversation on LinkedIn this week about, TDD or not, or how to start working, how to start thinking about that. How do you persuade yourself that you need to do that? Because often we know that there is no refactoring without testing. It means that you do need to write tests first, and people sometimes think that, okay, this is not value-added activity, so they simply not do it. Okay, and I think this is why we are focusing on this functional testing, which is not very recommended. It is in large scale, it is relatively difficult to maintain code quality purely with these tests, because you have too many edge cases. So you usually supplement that with unit tests. And some parts of the code are better to test it with unit tests. But this is so low effort that you almost immediately can go on to restructuring the code, which is an immediate value-added activity. So it means that you can re-app this and then deal with the edge cases and deal with these problems later. Right, so I am copying, I'm almost done it. I'm going to copy the tests as well, just to see how they work. Right.
Did you share the screen on Zoom as well, or?
I don't share my screen on Zoom. Do you want me to?
I'm thinking because there's maybe a slight delay, but let me check here.
Yeah, the problem is that I'm going to reorganize my scene, and then it means that we are going to fiddle with the...
No,
all right, so I have done that. Let's see if it runs. What do I need to do? I need to type in Titanic model.shell. And then you can see that the tests run. It means that the previous run, when I was running it in the notebooks, I saved these outputs, copy pasted the code into this shell script, this main entry point we're going to run. Let's speak a little bit about the structure, how this code is structured at the moment. Obviously, this is the first step of the refactoring. So your code is defined as a single class, right? And the single class have a single interface, which is a main entry point. One of these classes are instantiated here, and the main function calls main entry point, calls this main entry point, and then the business happens, right? And this is wrapped with a typer script, which is an excellent tool for any kind of shell script based programming. Essentially, if you have a typed input, you can specify it immediately recognizes of how to wrap this into a shell script. You get helper functions, you can have explanations, default values, anything you want, and all you need to do is write a Python code. This is from the creator of Fast API. I highly recommend to use this. All right, so let's take a look at what happens in the code. I'm actually going to close the notebook because I'm not going to need it anymore. This one as well. First, we are creating an engine connecting to an SQL database. We are running as an SQL. It has two tables in it, the passengers table and the targets table. Set the random seed, get all the data all the passengers data into a data frame, and then all the targets into another frame. And then we are doing some feature engineering, extracting better named columns, parents, children, and the siblings, spouses columns. We are creating this family size column, whether they travel alone. This is going to be relevant later, and of course handling the title management, essentially saying that some of the titles should be aggregated as a special rare title, and the rest should be their own title. Maybe this is somehow relevant to the estimation problem. And then just typical scikit-learn pipelining tools, testing and training at the same time. A confusion matrix is calculated, and then everything is saved. All right, so essentially we just need to go and through the exercises. So let's take a look at what's the first exercise. I am looking at, on the other screen, the pull requests file differences, reading the README as we are speaking, and then looking at what the code should look like when I am going to do the test. Right?
Great.
By the way, Matteo, if you see any kind of questions in the Discord channel, then please let me know. Sure. And we can do that as well. We can answer those questions. All right, so the first step, I'm step 4. I need to, step 4 was copy pasting the tests, right? So this one has 2 tests because we are going to test the pandas as well. So we are going to bring that code as well. We are going to put it here. Doesn't really matter. We are just moving code around. We are going to restructure it later anyway. And we need to include import OS. Neither of these are.
So just taking a step back for a second here, what we want ultimately is more flexibility, right, and faster iteration speed, right? Like we want to be able to switch things, experiment quickly, and this is done through a good code structure, right?
Yes.
So that we can change code and we're not scared of breaking anything. And so it sounds counterintuitive because you're spending a lot of time thinking about this, at least maybe initially, or so you think.
Yeah.
And then you're like, at the end of the day, the real benefit is actually that you're just iterating much faster.
Exactly. And there are other nuances here as well. For example, we are starting here with an original notebook. If you are experienced writing code in this way, you're never really in that state, You start with writing a code closer to the state of how it's going to look at the end. And because you have this kind of refactoring skill set, you are able to iterate while you are writing the first version as well faster.
Yeah.
So this is definitely a craft. So this is like maybe a 2-3 hour exercise. Once you do that, you should really immediately go into and find a project that you want to refactor and start working out, what's the right style to solve the problem, what you are working on. This is what people refer to as a craft. Craft is done by craft people who are getting better while doing it, right? And this is an important aspect, that you don't study programming, you do it, right?
Yeah, absolutely.
We're going to add one more test, which is going to be here. And then I'm going to run it, but obviously what's going to happen is, as you can see here, the last test which were passed was this X test processed, and now the last one is the df.pkl, the pandas test. So it means that we can see that obviously this file didn't exist before, so this pandas testing program just saved the current version, but when we are running the next iteration, then it's going to happen correctly. Right?
Yep.
So the first step is to decouple from the database. So this we're going to, let's take a look at what does it mean. All right? So here you have this class and essentially your main program. The main program has these connection string built into it. The engine and the SQL connection is built into it. So it means that if you don't have this database, there is no way to to run this code. And this is one of the primary aspects of clean code, which is called experimental operational symmetry, is that there is only one version of the code. There is no prototyping, there is no transformation or translation of one version of the code into productionized code, because that is an expense on its own, and it creates a lot of friction, because now you have two versions of the code. You have never been sure that they are doing the same thing. It's much better if you have only one version of the code. You maintain it throughout the entire project. You might have less features in it, but we are going to see that in a clean architecture situation, often it's easier to write in clean architecture than actually trying to simulate some kind of infrastructure. Like, for example, here, you can see that the data is coming from a database. You can imagine that if this database doesn't exist when the prototype you are creating, then this code will never run. All right, so what can you do? The best would be if you get the data from an anonymous source, and then you can swap this source in and out, and sometimes you get the same data from a file, sometimes you get in from a database, but in general you are not going to know which one it was coming from, right? Essentially what we are going to do, we are going to write a class for that, and then plug this class in. So what does this class do? So this is an SQL loader. It says what's on the tin. By the way, the code is formatted with black. So essentially we standardized, and we are using the correct snake keys everywhere for variable names, and Pascal keys for the class names. That was another refactoring exercise as well. It has two entry points, essentially calls this query, and this query, and get the data from it. All right. So what do we need to do here when we are actually, we need to instantiate this loader. So this is the first step. We are going to get rid of the database in 2 steps. And the same df data frame will going to arrive from this file, and the other one, the targets, will going to arrive from this, and then I can drop everything else apart from the random seed. So I'm going to move it over there. So what happened here, I'm going to do this as well. Right, so what happened here? Obviously, we are still hard coding this class, but now we are one step ahead, because obviously now the implementation of how the passengers and the targets are collected are disappeared, right? Because you only know that we need this class, right? So what's the next step? We are going to extract this loader into the class. This is what we call dependency injection, because this loader is a dependency, right? Where the data is coming from is a dependency, and this dependency is hard-coded into my code. It means that it is coupled. So it means that these two cannot exist without each other, right? What I would like to have is these codes can run without each other, decouple them, and at that point I can develop them separately, or I can replace one with another. For example, in an early stage, I might get the data from a file. In a later stage, maybe a software engineer will going to create me a connector to the real database, and they can put in the necessary checks into it, and I'm going to get that data. And when we reach that stage, we are just going to swap the two together, and then we will going to continue with the same code base, right? But this code, what I'm using, is not going to be edited, right? So I'm going to remove the instantiation. Actually, I'm not going to remove it just for now. I'm going to put this here, but obviously now, because it is a parameter, now I need to edit and move this piece of code. So I'm going to edit the constructor as well, or the instantiation. Here in the main part of the code, I'm just going to insert this like this, and then it's done. All right, so essentially what I did is moved the loader creation into the main part of the code. If you think about the structure of an algorithm of a project, you can think of the main part as an experiment, right? Like this is running an experiment of creating a model in a certain context, all right? The context is that I'm getting the data from a database. For now, there is no other parameters, but we are going to see later that you can have other parameters as well. And together, these act as an experiment, right? And this is the rest of the code is the organization of this experiment, right? So what is the gist of it without the necessary details, and the details are these adapters that you are plugging together a complex behavior, and this is going to be your experiment, right? And you can think of the productionized version as well is another experiment when you are plugging in productionized components, right? So let's take a look at.
And another word for this generally is to compose, right? You
Yeah.
compose complexity, right? A behavior.
Yeah, very good
together.
point. Yeah, exactly. This is so you need to prefer composition over writing code or coupling code, because if you compose, you can delay the composition at the latest point, and because you delay the composition, it means that you are going to have the most information of how to structure your code. So this is not just about like, okay, when I start writing a machine learning project, sometimes the productionized systems are not in place yet, right? So it means that there is nothing to connect to. I can get the data from, but I would like to prepare for when they are arriving and simplify my life and change only the necessary part of the code. Right. So what's the next?
And so So sorry, just one last thing. So when you mention like trying to delay it as much as possible, you're basically looking at the entry point to the code, right, which is the main function, right, and that's where you then plug in the various parts,
right? Plus delaying in terms of in time, in the project time, right? Because that's the problem is if you make a decision very early on and couple your code, that's going to be technical debt because you are essentially made a commitment while you have no idea about the whole project. And this is a big problem in technical projects, or especially in machine learning projects, because you need a lot of kit early on to set up your project, and you need to make calls whether you use a feature store or or a model registry or all of these components. You start writing them, so you make these calls, but you don't know whether they're going to be important or not. And you have a lot of like algorithmic choices and so on, right? So the next step is we are going to demonstrate of how to practice this this composition, and we are going to replace the loader with a file-based loader. This file-based loader will going to look at two files, save these passenger file names and target file names into the disk. And if these files are not existing, they are going to load it from get the data from a real loader, so the SQL loader which we see before, and they're going to save it into the disk. So the next time when we are running this call, we are only going to have file operations. This is happening often where you don't want to stress some kind of external resource with testing, but you can imagine that once you detach yourself from the database, you can run tests infinitely many times. This is going to be much faster. If you want to cut the data, what's available from the database, you can do it here and then just return less data, and this is going to run even faster, right? And the next step, this is going to be step 8, when we are going to add this test loader. So instead of this, I'm just going to comment this out. Actually, I'm not going to comment it out because it's not going to run. Right? I'm going to create a different test context. So I'm essentially keeping my productionized context. All right. So you can see here that I am. I'm not editing the version that is going to go into production. Like I'm pretending that the main code is going to production. I'm writing a test version which has this test loader, which, as we see, doesn't or very rarely goes to the database, but otherwise it's based on files, right? And it's going to run the same code, and I'm going to replace here the test, the main entry point to the test entry point. So from the rest of the project, we are going to run this part of the code. Obviously, in a real setting, you would have these in different files. They would have different parameters in the shell. But I would let you figure this out on your own. All right. So let's run it and see what it does. Right. So it was running. So it means that we didn't have two serious bugs. Actually, let's make a commit. The benefit of that is that now obviously I have a checkpoint, that's important, but the other thing that I'm going to see what I'm editing here in the side of VS Code. That's an additional benefit of frequently changing. All right, so the first step of changes is let's aggregate the passengers' data with the targets. Why do we do that? The reason is because here you are getting these data separately, but the survival rate is part of this passenger class or data, and therefore you are kind of like having these two versions of moving data around, and that doesn't sound good. I'm sure that this is better if we going to replace with a different query. So I'm just going to copy paste the query from here.
Yeah, and I think this is really interesting because I think it also just goes into this idea of, I think, matching kind of, the business side of things, maybe language or specific terms. I think we speak of ubiquitous language, right? And you're trying to map what's going on, the problem you're trying to solve, you're trying to map it to objects in your code. And I think naming the classes or the methods, proper naming, maybe referencing those real objects, I think really helps them in terms of communication as well, right? And so this idea is that the targets and the target is not an actual entity, right? Target is just a characteristic that's part of the passenger, right?
Yeah.
So I like this idea here.
You should somehow refer to as is survived, isn't it? Because that's what it meant. Like this is usually what's called ubiquitous language. It means that you should name your variables and your classes in the same way as the business context you are doing, because obviously then you are going to use a language that is naturally connecting to your business stakeholders, and also you don't need to translate in your head that actually when the marketing says transaction, that's in this data frame. All right, so in your mind is in one.
Right.
Like if marketing is talking about transactions, then you have a transaction class, and then there is no translation, and you simplify this again. All right, so I'm just going to delete the other entry point. We are going to remove here. Obviously, there is no targets file anymore. Cut this one as well.
Yeah, and we'll see that this simplifies the code a little bit already.
Exactly. So what we are going to do is remove the targets. Right. So the target, this one is removed, but here, obviously, I need to put it back. So. Okay. So the targets should be equal, and then we are going to create this list comprehension. All right. Let's see, and then it's in the code somewhere. Oh, here. Okay, I should not have written. Cool. All right, so this is done. And then what else I need to do? Here, I need to, obviously, because my test loader is saved the file in the previous iteration, obviously, if I just remove this, this file that we just saved doesn't have this is survived. So actually, we can run it and see what it's going to do. It's going to fail in some way. All right, target file is not defined. Okay, we're immediately in testing mode. That's because Obviously, we should have constructor remove that as well. Let's rerun it again. As you can see, I'm not really thinking about what to do. Yes, because this is wrong. This is wrong in the code. Yep, it's wrong in the code, so we can change that later. And yes, so this is failing. Why is this failing? Because obviously, when we in the test run and the previous run with the passengers, we saved that data frame without the survived variable. Obviously now, because this is a test loader, it doesn't go to the database if it doesn't need to. Right. So we need to tell the test loader to ignore what they have now, run to the database, run that query, because obviously now the SQL query loader here run this query, right? And then it's going to have the is survived variable.
Yep.
Okay, so let's
really you should be expecting it to fail here, right?
Exactly. Yes, it's a bit weird because obviously the reason why it is failing is because you are using the cached version. If we would replace and rerun this one, then it would correctly run, because obviously this goes to every time to the database, but this only goes to the database if you say so. So we are going to just rename this with is survived. All right, this is. Obviously, you can have these kind of methods for this and figure out how to.
Yeah, I mean, every time you're changing the data loader, you're going to have to change the test file.
Yes, You essentially trash the cache, yeah. and then you get a new version in the next run, and then you can go on. And so this was expected, and this was when I referred to it, that if you change the behavior, then you expect it to break in a certain way. So the next step will be, we talked about ubiquitous language. Obviously, we should represent the passengers as a class in the project. So we are going to create a PyIdenti class for that. If you're not familiar with it, I highly recommend to learn how it works, because essentially this is where what we are using for any kind of storage and JSON-based in and out copying. It works on hierarchical structures as well. So in one go, you can solve a lot of problems. And the first thing what I'm going to do, I'm only going to copy paste. Obviously, the original repo has an example of what's the data in each of these classes. Obviously, in a data frame, you don't really have a strict definition of your data model. So you can put a string into a variable, into an integer or a float in the place of an integer, and then it's arguably questionable of what does it actually mean. So for example, here you can see that cautiously I'm converting these variables into an integer, because I don't know whether the targets in this file is integers or just a 0 character in a string or anything like that. Obviously,
that's good to be explicit here, right?
Yes, exactly. Yeah, it's usually the answer, like explicit is better than implicit. It means that if you can write it in a way that it actually precisely tells you what it's going to do, then it's better than you imply, let's say in a data frame, the column type, and if it doesn't work, not like that, it silently fails and then just keep continuing. And these are usually bad practice, because it's not too difficult to set up an explicit way of solving some problem, but it immediately saves something when an implicit behavior is broken, all right? And an explicit situation, it will going to immediately fail. That's what you would like. If something changes, you would like your code to break, right? Or send you some kind of signal that it is in a state, it experienced the state that it haven't seen before, right? Okay.
So by using these data classes, really, we're adding robustness in that sense, right?
Exactly.
We're taking in data, and we're like really setting that schema. We're being explicit on the data types, and this is something that is not necessarily what happens with data frames, right?
Yes, exactly. And obviously, what happens is you don't have a strict data model. It means that your code will frequently have checks to verify that your data is still in a certain place. And this is what you say with this, that once a class is created, usually data classes are immutable, so they are going to be in a state that their definition is, and if some kind of source tries to create a class that should not exist, then it will going to fail at the creation, and then that it's not some algorithm fails because it experienced like a negative number where it should have just positives, or an out of bound index or something like that, because then you don't know what broke. Like, is your code wrong or the data wrong? All right. But if the data breaks at the creation point, then it can be only the data, and you don't go further, right? Okay. So the next step, we're going to write a class that is going to encapsulate instead of data frames, it is going to load passengers, right? So now we have this passenger class. It has several fields, and each of them has its own type. So essentially, we clearly define of how this is working, and then the passenger loader is going to take an SQL loader just before, and then creates these classes with the appropriately defined fields. Some of the feature engineering is happening here. This is about style, whether this makes sense. Here it makes sense because these are relatively straightforward, and you can justify that, let's say, the family size is part of the passenger class. It is essentially a data imputation question, right? This is the format you are getting the data, and I know that this is going to be a better format in the future to be. So I would leave this here. Obviously, you can, why? Because you have the refactoring capability, you can move this out later and then try something else. All right, so we are going to put this here, and that's a good idea again. Obviously, just to show here, obviously here we are getting every single field from the passenger class, and according to the analysis, these 4 fields are never used later in the code, and this is part of this explicitness. It means that only get the data which you are going to use, and if you need something else, then consciously add it. So it means that you have the code base in the minimum viable state, the least amount of moving parts. You're not doing extra operation, and that also have the benefit of, if anything changes, you would like your code to somehow tell that it is getting a different named field, a column name changed. These are all explicitness questions that you would like your code to be sensitive to, because you do it once and then it's a peace of mind. You don't need to worry about anymore.
Yeah, absolutely. Yeah.
Cool. All right. So the next step is, obviously, after we looked at which fields are not used, that in the query we are going to collect only the parts which are going to relevant for us. I'm going to copy paste it again, so you don't need to watch me struggling with the keyboard. And I think that it is a good time to give it a try to run the test and then see whether it passes or not. It's not a problem if it's not passing, but here it was passing. Why is that? So we removed these fields, but the tests are still passing, right? Is that strange? Why is it not strange? Right, because obviously, so what happened?
You're still using the test file, right?
No, that's not, because clearly we are getting the data here, right? And then process this data, and then here we are throwing away columns that we are not going to use, right? So we download this data from the database, but we never actually use it. And because the test is here at the end of the code, all right, it's just here. Actually, it's just here. It means that it never saw those obsolete columns. Okay, so this is another situation where you can be confused because there was some code in it that have never actually looked at. It can be in any state, so it is better to remove this. And actually, I'm just going to move these. up here.
Right, I see what you mean.
Very top. And right, so I move the test codes just out of the way, and then I immediately run the test to see it's passed. Where are we? Passenger loader. Right, so it means that I just made a check-in. That's good to use. Obviously, in a real project, these would be in separate files or at least better structured. The reason why it is in one file in an exercise, because then while we are doing these exercises, we just need to up and down scroll and talk about the code, but not
right.
Actually.
But I think it's also good to mention that I think a good time in general to commit, right? Just to smaller commits is every time you refactor, you rerun the test, you see.
Yes. Yes, usually like a good Git flow is very important to get used to it. And as you can see that I'm typing the code, the Git commands into the terminal. I don't use any kind of other tools. I like to write these because committing and pushing and creating new branches, these are conscious acts. You know, I like to look at this. Sometimes I look at the changes here as well, that when I'm making a commit, I look at whether I'm committing the right code and then open a PR or pull request and then look at on the GitHub, because you don't just throw code into together and then just shovel it into GitHub. It's a conscious activity when you're maintaining like a consistent state of the code. It means that if someone else is using your code, you're respecting their time as well, because they are going to review your pull request. They're going to read your code. Code is read 10 times more than written, so it means that you are really saving a lot of help for other people if you are doing this for them. Cool. All right. Yeah. So the next one is we're going to move a couple of things around. This is step 13. Essentially, what we are going to do is first is using the data frame generation. Maybe I can talk a bit in how do you start refactoring, because until now it was mostly about setup. You want to detach yourself from any kind of external resource that you are using, so it means that you can run your test code as many times as possible. Probably if it takes too long, like because you are training a model on a lot of data, you can figure out how to restrict that or filter down that training set, or loading the data into a trivial amount that you can continuously run and still see a code running. All right, so once you have done that, the next step is to take a look at the code and of what it does. All right, so what's happening here? Here is the feature engineering that will going to happen in the passenger, and then there is some kind of training data creation. Obviously, you can see that the training and the testing files are very similar, and they are mixed together. All right, so this is like a classic example of something like a code smell or a problem that you need to look at when you are doing it. But essentially, this code has like a data flow structure. It starts at the beginning. It gets some data. It transforms this data in pure Python. Then it scikit-learn. Then it trains the model. Then evaluates them, then saves them all. So it's a natural way of progressing with the refactoring from a top to the bottom. You go forward and always make a changing step in a way that is not going to be too arduous and doesn't change the bottom part of the code, which we haven't touched yet. But as you go forward, you have more and more clean code, right? Okay, so we are going to ditch everything here until the targets. Right, so we don't have this anymore. We have this. So what's happening here? Essentially, we are taking the passengers. Don't forget that now the loader is a passenger loader. So we are loading a bunch of passengers. And then with Pydantic's dictionary converter, we are going to turn them into a dictionary and then convert that into a data frame. Now, what's the point of that? The only reason why we are doing this, because now we get back the same data frame that we had before. Right? We can ditch this as well. it means that the rest of the code doesn't need to change, right? So, and this is like a logic in refactoring, that you are always trying to not interfere with the non-changed part of the code,
Yeah,
right?
step by step, very small steps. Make sure that
Yeah.
the state is, is kept stable, right?
Exactly. It means that if I want to run the test, I'm actually going to check all of the rest of the code as well. What do you need to do in step 13? Obviously, the passenger loader, you remember that the passenger loader have this rare titles variable, right? So these are a set of names that were generated by a previous code. Let me get this back for a second. So this was the code. I'm just going to put it here. Right. So this was the code. What does this code do? It essentially takes the entire data frame, does a counter on it, and then anything that is less than 10 will going to be part of these rare titles. And then in the next step, it's going to replace whenever these rare titles, the title was in these rare titles, with the word rare. So what's the problem with this? Like, obviously, if you would think a productionized system, and then you are getting these passenger classes one by one, you don't have access to the rest of the data frame, where is this information coming from? Like in a productionized system, this is usually maintained by another service, all right? So that service somehow keeps track of all of the passengers and only, counts how many of each of the titles there are, what are the frequent ones, what are the infrequent ones, and then you ask that service for that. And this is what we simulate here. So, you shouldn't have a part of your code, because don't forget that this is the same code that is going into production. So it means that you shouldn't have a part of the code that is incompatible with productionized environment. All right? Because if you are going to do it later, then at that point you are going to rewrite this code. All right?
Yeah.
So essentially, to cut things short, I'm going to just copy paste this. Where is it?
So yeah, determining these really needs to be a separate process.
Exactly. You can write like another class, for example, that has an interface that can get it one by one, and but this is a pretty niche problem, and it's an explicit problem. You do have problems if you build these kind of assumptions into a code base. By the way, did you check whether we are correct in the live stream?
If we're good, yeah, we're good.
Yeah, we're good. All right. Okay.
In terms of quality, audio, everything, yeah.
Awesome.
Hear both of us.
All right. So what else do we need to do? All right. So we can remove a lot of code because all of this code is now happening here in the passenger class. All right. So we structure these classes correctly. We only return a set of a list of these. The rare titles are here. So here the code is much shorter. It's not really the shortness that counts, but it is expressive, because if we want to change how the passenger classes and the backend data service is happening, then we need to go to that class. All right. So we don't need to think about it here. When a passenger class comes out of this class, then that question is done. All right. Like we know that we are in a consistent state. Okay. So what next step what we need to do, because obviously now we are using passenger titles, so we need to change both the production version of the code which require an SQL loader, right, and the rare titles, and we also need to change the test loader, which is wrapping the previous loader, because that's how it works. So I think I didn't speak about that, of how exactly this is working. So essentially, as you can see, this passenger loader doesn't have any kind of data IO related code in it. The only thing what it gets is a loader, and then uses that loader's get passenger, just like the previous code, to get the raw data, and then turns these raw data into a passenger class, and then returns that passenger. So it essentially, this only does transformation, so we need to provide it with an connection to an I/O solution, and here, obviously in the productionized version, you are connecting directly to the database, and in the test version, you are connecting to the file-based loader, and then you get the same behavior, right? But the passenger loader is the same in both cases. And then I'm kind of going to run this, and let's see whether it breaks. And it breaks.
Yeah, that makes sense here.
What do you think it's the reason?
Right.
One of them has 2 less columns. So what we can do is here, when the test, we're gonna write into it. So this is the pandas test is failing, all right? So this is failing. It means that this assertion error happened here, this assert frame. So essentially here we can do this. It's going to tell me, or going to print. So it's going to tell me what's the difference between the 2 columns, right? And then maybe that's going to reveal of what's happening. So one of them has a PID. What's a PID? And the other one doesn't, right? So let's take a look of what did we remove that has any kind of PID related. That's a passenger ID, right? So the left is the new one, and the right is the is the class, right? Actually, let's print them one by one, right? Yes. Okay, yes. Of course, because here in the data frame, here in the data frame previously, you only saved the columns that were relevant for generating features for the model, right? But now, because here you are generating everything, you are getting back all the fields, and the passengers have the targets in them, right? The target classes,
right,
and the is survived as well. So these were not part of the data frame at this stage, right? When it reached this point, all right. So at that point, the is survived is removed, because there were this line in the code. Let me find you and copy paste it back. Yes, this one. So this one, which is, yeah, this part is the part which removed the PID and that is survived from the data frame, and therefore you can. So essentially, what we are going to do is edit the file, the same trick what we did before, and then we are just going to rename this file. We say. Right.
So it's important that we're allowing ourselves to change the file, right, and have the
Yes.
test pass, because we understand the difference, why it failed, and where the difference is, and it's exactly what was expected.
Yes.
Actually, right?
Yes.
After analyzing the right?
Exactly.
So not cheating or anything. It's important to keep in mind.
I mean, this is a work in progress. So essentially, you are trying to have a workflow. Like the end goal is not to be like somehow purist about the rules, what you're doing here, or somehow hair-splittingly committing to certain behaviors, and this is an important part. This is not just to copy paste code from one place to another just to make it look like one way. Like this is a purely value added exercise, and it needs to happen like an efficient way as possible, like 80-20, like 20% of the techniques will going to give you 80% of the value. What do you want to do? You want this experiment, this one, as flexible as possible, right? So like you want to have, and when you sit down to refactor a piece of code, you need to think of what do I want to do? Okay, why can't I do that, right? Not in terms of like business added value. What kind of value I want to, what do I want to achieve, all right? How to make my job work, all right? And then look at your code and it's like, I can't do that, right? And why you can't do that? And then you answer that question, and that answer is where you need to start refactoring, right? And then you can say, okay, I see I need to rewrite this because I'm coupled with this. That's why any kind of change in this area will going to be cumbersome, all right? Or I don't understand what this piece of code does every time, I need to change it, like I need to re-implement, rerun it, and then, go line by line, refactor it. That's a readability issue, and so on, and so on, and so on, right? And then you get it as a second nature. And obviously sometimes you can write it correctly in the first go, and this is, this is an indication that you are better at what you are doing, but you can always go back and fix things, right? Yeah. Cool. All right, so we have done that, and then we fixed the loaders, and then we are at point 14. Okay. Go ahead.
What's nice really is that some of these, like what we're seeing here, some of these basic ideas, adapters, loaders, sources that you can then switch, that's going to become second nature. So every time you'll start a new project, you really start writing those kinds of classes, and you already be decoupled from a data source. So the way you do this, just more it'll be second nature, like you said, and then you can get into more sophisticated situations, maybe more sophisticated processes where you'll start thinking about, all right, when do I need to start moving things, et cetera, right? But at least these basic blocks that they'll really be second nature.
I think the loader, so this kind of adapter type, factory type classes are like standard. So it means that I'm always thinking about where am I going to get the data in the future, where am I going to get it now, and then how can I isolate from this problem, all right? In the main code where I am dealing with feature engineering and model selection and any kind of esoteric stuff, I don't want to think about whether a column is a string or an integer, right? This is like what's defined as layers of abstraction, all right? So this is like a principle of system architecture where most of the time you would like to think about high-level problems because that's business problems, all right? I want to think about how I solve business problems, not how can I convert efficiently strings to integers, right? I mean, who wasn't there? When you really have like a hairy data frame and then you have no idea why this column has nuns in it, right? Or why is the column type is object? It's supposed to be integers, right?
So you should start seeing this pattern in your code, right? Where parts of your code, you should really see the layers of abstraction in those, right? The lower level details are abstracted away into their own classes or parts that you plug in, right? And then, but the main part really is the higher level.
Exactly. And I think this is part of the presentation on PyData about clean architecture, is that these are concentric circles and the business problems are in the middle, and then you want to be there a lot because if you set up an experiment, when you try something out, that's a business problem, all right? Like, would it make money, all right? Or can we solve this problem, all right? That's a business problem. You want to deal with business problems there, where the data is coming from. You don't want to deal with this. You want to outsource. Like, if you are decoupled, you can even outsource it. Someone else can do it, and then you can focus on that, just the other part. Maybe someone is better suited for that, or a junior member to get onboarded, and then you can work with them better because you declare a clear interface between your work. You don't need to know how it works, and this is primarily what abstraction is about, is that you can use it without knowing how it works, all right? Because if you don't know how it works, then obviously you are isolated from it. It can change if it stays the behavior the same. It means that someone else can do it while you are concentrating on something. So the next step is like, if you look at the code, and I mentioned this before, there's a lot of this test and train code mixed together. So what I would like to do is somehow separate these, because I would like to have a training phase and a testing phase, all right? So essentially, I am going to move anytime there is any kind of testing, I think I have a... Actually, I'm just going to copy paste it at the very end. So y estimation is the last line. Okay. Like this. And this have every single test code is here. So essentially now in the test part, I'm just going through, there is this test category called one-hot encoding. I'm extracting from the test data the numerical ones. I'm using an imputer and the scaler. So I scale these and then stack the two together, and then I use a prediction, right? So I can remove any kind of test related code from here, right? So this one, this one, this one, this one, this one, this one. So I am just reading the beginning of the rows, and then I can run a quick tests whether every it's here, this part is none, and then it's here, right? So it means that, okay, so this is at the right place. Let's run it and then see whether it runs. And it runs. So it means that we haven't changed the behavior. So it means that now it's separated. Like I have a training phase and then I'm having a testing phase, right? So this is my already a clarification. Plus, actually,
very simple, just moving the code around, right?
Yeah, exactly. Like so far, very little original code was written, but we progressed forward and we have a clearer idea of what the code should do. Okay, so the next step is, all right, so essentially you have this class, which is a one-hot encoder, and then an imputer, and then a scaler, and then the model itself, all right? What I would like is to have a class that connects these together, right? So essentially, everything what I want from it is in one class, because these belong to each other, and then it would be better to not creating this ad hoc in the. All right, so I'm going to create a class here, and
they're all part of what you like to call the modeling context, right?
Sorry, a bounding context.
They're all part of the modeling context, right? The problem where maybe when you pre-process data, you work on features, and then it's all connected to the modeling part of the problem, right? And
yes.
Be like the layer of abstraction. You just put it into the class.
Yes. So essentially, you abstract this away and you move it one place. And essentially, what happens is that this model creator will be only concerned about logistics. And then the modeling bits happen in one place. So if I want another model, I can just rewrite it, and everything will be fine, right? Actually, let's not do this. Let's not implement it, right? Right, and then because that's better if you do it with like this, because. And I think it needs the passengers as well. And then this is an estimator, right? You can write any kind of. It's a good idea to do this, because when you're refactoring and accidentally you call it, it should throw an error, right? Because we haven't thought about what's going to be a training. Because the purpose now is to move the construction of these classes out here, right? And then in the body of the class, we are going to instantiate with one go here. Which also means that I can remove any code that is making these and then replace it. So the constructors, but not the fits. All right, we are going to deal with this later, but for the first step, I'm just going to use the model variables instead of here again.
So again, you're being very explicit with raising the not implemented error, right? That's another example of explicit.
Yes, it's better to do it this way. And actually the IDE help me is telling me that I'm using a variable that doesn't exist. So here as well, obviously I only need to use a fit. So essentially I'm constructing these classes at the same pace. You don't need to really worry about this, because obviously the model will gonna fail immediately if you are forgetting to change one. Obviously, you
Right.
can see these are underlined, so these are here we are going to use as well. What was the name of the predictor? Right, so it's called predictor in the model. So we need to call the model.predictor, right? Model.predictor.predict, right? So we fit it, and then we are running the test estimation, and then in the testing version, we are going to use the same classes. But now we are grouping this together. So essentially we are converging to a state where we are going to have clarity on what's happening. Here is a predictor. Okay. And then let's run it. Right. So this was a relatively large change, but essentially if you look at the PR, you can see that all of the green what I was writing into it, I'm just writing model and removing classes and so on. So it's not very intellectually challenging thing. It's just fiddly, and this is exactly why you have a test, because it's now you can run the test again, and then it's going to tell you whether you
Make sure you
forget
didn't
to.
miss anything.
Yeah, if you forget, if you know, it's like who cares? Like I remove here one, I run the test again, and then of course it doesn't work because it's like. So this is what testing gives you. It's like I don't like I'm talking to you by writing this. So it's like it's not an easy thing to do.
It's a good safety net. You're confident about it.
Yeah, exactly. Okay, so this one was going to be a bit hairy. It's not too big of a problem because what we are going to do is handle this. Right, so here you have passengers. You remember we undo this, and then we get the targets. And the only reason why we are doing this is because the rest of the code deals with data frames. But what we would like to have is these classes be like the passenger class should be used everywhere, right? So when you deploy this model into production, and then something calls this Titanic model class, because essentially this class is that's going to be deployed, all right? So you can think of it as a proto service, and this is exactly why using classes is a good analogy or to services, because you can think of a class as a service, and then you can think that, okay, I'm going to give this class to someone, they're going to wrap it into, let's say, fast API, a Docker component, deploy it somewhere, and it can work, right? They only need to think about the glue parts, they don't need to rewrite the entire thing. And so where was I? And of course, when they are going to call this, they are not going to have these data frames, right, around. What they're going to have is probably some kind of JSON, all right, some kind of REST API. They get it from some database, or maybe they have it in memory. They call some kind of, client, like some kind of interface, and then pass it on to the server, and then the server will need to do something about this, all right? So what I would like to have is the classes and these services between them, we are going to pass these domain classes to each other, right?
Right.
And for that, obviously, one of the biggest breakpoints is that here, I'm dealing with data frames. So what I'm going to do is I'm going to remove that class, that row. So I'm not going to split the training data here, but I'm going to write different. Okay, actually, sorry, not here. This is part of. This is going to be part of the model creator class. In a different situation, obviously this is a splitting policy. This can be part of an experiment, right? So you can think of it as like, okay, actually I have the passengers, but I would like to have a different strategy for this. Typical situations, obviously random sampling. You can have some kind of temporal sampling when obviously the first part is the training data and the later part in the test data, and you can experiment with these ideas. Then you should decouple this as well. Obviously, we are not going to do that because we decoupled something else from an exercise point, but that's exactly what you are thinking about. So what happens here? Obviously, these split passengers, obviously, eventually we are going to call the same function with the same parameters, as you can see on the PIDs, but here, first, we are creating a passenger map. Obviously, the scikit-learn's train test split doesn't know about our classes, all right? So we need to help it and convert some data out of our data set into a format that it can split. So the first is we extract the PIDs from the passengers, and this is what we are going to use for splitting. And obviously the original implementation, this line is the same line as here, as you can see here, right? So this part. So it means that, yeah. So it means that we are using this to recreate this the stratifying variables, which is the targets, and use that to create the beginning and the end, or the training and the test set, and then using the same map where we had a mapping from the PIDs to the passengers, we're using the same map to map them back and then return the passengers. And the good part here is that this kind of detail of how do we split these are entirely segregated into its own place, right? So this main code will not going to know anything about this. What we can replace here, passengers equals.
And this mapping is key because the data that's saved right now, the way it's divided, it's got a certain order, right? And since the splitting is random, you need to set the order back with the PIDs. And this is
yes, exactly.
Map it, right?
Yeah, this was one of the biggest problem what we did in the previous one. That was a more convoluted way, but it's better to do it in one go and, once and for all resolve every problem here, and then you don't need to worry about it ever again. Right? So here. You're going to replace passengers with this. And obviously it starts to clean up.
Yeah,
and then
it's nice because it's really emptying the main run method, and so you can see that you're just pulling out the little bits and pieces.
Yes.
The process, and you're abstracting them away in either their own functions or classes that you plug in and everything. This is really, you can see come along, right?
And obviously, as we did before, instead of, because we don't want to touch this part of the code, so because we refactored that, and this was returning these data frames, we need to recreate these data frames in this code. And this is exactly what we are going to do. And essentially, we are recreating the classes from those parts that we created, right? And if we did this, the test should pass. And then something is broken, and the reason it's broken because here in the tests, obviously we remove the data frame as well, so this is the reminder, because now we have the passenger class, so we are essentially moving, if you remember previously this list line was this, right? So the data frame we recreated from the passengers were converted back into a data frame, and obviously that's why this test was passing. So what I'm going to do is I'm going to take this down here and then insert it. But this one is a typical case where you would think that, okay, can I test it somehow differently, right? Okay, so one bracket and then another bracket. Right, so maybe you should test the actual data, or have like assertions. Pydantic has tests as well, and then check the actual classes whether they are the same class as, and don't do this convoluted. Maybe in a future version we can do that as well. Obviously, you can see this is passing. Cool. All right, let's do. Which one was that?
Good.
Cool, right? And we are at step 16, right? So it means that it's almost end game. Yes, so we are actually going into the scikit-learn refactoring. So obviously the first step, you can look at this and then it suspiciously look the same, all right? So you are calling the same codes. Here you are using the same constant lists, this is somehow suspicious, all right? And the first thing what we are going to do, we're going to introduce a new concept that is processing the data for both training and testing. So it means that we only have this code once, right? So we are going to again, I'm going to copy paste. quite a bit
Going to
of code.
remove a lot of duplicated code, right?
Exactly, and this is essentially the same operations should happen. You would like to have a confirmation that when you are converting your code at training from raw state to feature state is the same code that when you are
Yeah.
going from test state and inference,
Yeah.
usually you think about inference as the same as testing, but have one version of the code, because then when you edit it, it will going to pass. Because often
Yeah.
in this state, you can think of these as aggregated tests. All right, you are essentially testing the confusion matrix. It can easily happen that you made a change that doesn't change the confusion matrix. All right, but you are still already some samples. You are making mistakes. All right, and this is one of the reasons why this is this is here. That like the training and the test processing to make sure that smaller changes are failing the test as well. All right. And that's an important concept that you would like to have like smallest change to break your tests. Okay, so we are having this quite a bit of MLF here, quite a bit of code that is going to. It does the same thing as before. So it takes the passengers and converts them to the data frames and then extract the right part. If the model is trained, then obviously we are not going to retrain the one-hot encoders, the robust scalars, and the imputer. But if it's not trained, then we are going to fit transform and then return the values, right? So essentially this is a bit of a domain-specific code, and obviously we would like to have a tool here which says if the model is trained, this trained field will going to be set by the train function, right? You can write something here like you can have guard calls here. If self-trained is equals to false, then you are not in a training mode, then throw an error, because then you're trying to run inference on a model that haven't been trained. You know what exactly you are expecting, right? And you need to be careful, because obviously this is the same code that runs in training and then it wasn't trained. So, you need to figure out of how to pass that information to.
Be as explicit as possible again. Yeah.
Okay, all right, so this one is done. And then here at the training part, because obviously now this entire part of the code, this one is moved. So essentially this is the train process. So as you can see, this is the variable. So stacking the two versions together, you can see that this is happening here. The categorical data and the numerical data is stacked here. So this is essentially the same code as running here from here, right? So I can ditch this.
Yeah.
Because these are.
It's kind of interesting because are you familiar with the pipeline object in sklearn? Yeah, I don't know if you've ever used it, but I'm actually seeing this maybe that what we're doing this model class, which is wrapping all of this logic, it's actually basically the same thing, right? Because the pipeline, the cool trick about the pipeline that people like is that if you throw it in a CV or something, whatever, it's going to flip on either a fit or fit transform, depending on if it's test data or train data, right? But we're actually doing the same thing.
Yeah, that's a very good, and obviously there is a reason for that, because this is the right way to solve this problem, all right? And scikit-learn provides you a relatively generic structure that is capable of solving most of these transformations. But for example, in other situations, this can be any code you can imagine, all right? And for example, that's one of the biggest problems in scikit-learn, that the pipeline elements needs to be either scikit-learn code or some code that can be pickled, all right? And that can be a problem, because obviously when you pickle something and then you import it, the place where you are importing should have access to this the code that is included in these functions. But here, this is not a problem, because you can write.
So if you want to add like a step to our pipeline, you just add it to the constructor, right? You add maybe, we have a scalar, maybe you switch to scalar, maybe you add PCA as a member, right?
Yeah, like this is pure Python code, so you can do whatever you want. Like that's the benefit of the structure. The important part is the same code runs in training and testing, so there is only one version of it. So if I change this, let's say I don't want to scale, right? So I cut this and then I just return the numerical data, right? No, actually, yeah, I just return this, right? Here, then I know that the test version immediately get the same one. It's not
Yeah.
possible that I actually forgot to like in training I removed it, so it's not going to be trained, and I run it, and then in the test version it's still using it. So obviously now it's an untrained scaler. We're going to scale my my output, and then I'm going to look at this like this was a bad idea, and then I don't know because the values what I'm looking at is buggy, right? So these are important. This is one of the reasons why having one version of the code is a good idea, and then.
Absolutely.
And then we can ditch this one, and the reason for that is because obviously now the predictor takes the trained passengers. Actually, I'm going to do it now. All right, so the next step, 7.18, we are going to move the training part into here, right? So we are not going to do the training outside of it. So what do you need to do with the passengers to get a trained model, right? So very easy. We extract the target variable from the passengers and then generate the inputs with the code what I just wrote with the passengers. We are going to fit the predictor, and then we set the trained variable of the model to true. It means that for the first time when you're training the model, it's going to run through this branch, and obviously when you are in testing mode, you are going to run through this branch, right?
Yep.
And that's important. Like, yeah, that's a bit weird that you do need to have it twice, but you do different things with it. And then you can structure a bit differently, but that's probably not too important. Right? And that means that here, where is it? Here. Instead of, I can just do a train, and then train passengers. Right? And then I can remove this line definitely, but not this line. A little bit confused. Still need this. You still need this because we haven't wrote this function, which is the estimate version, so you don't know how to create this without straight from the model object. Okay.
Yep.
So what's going to happen now? Let's run the tests. It looks good. All right. Yeah. So the next step is we are going to move the prediction as well into. But that's the easier bit, right? Because essentially, the only thing what we need to do is convert the passengers into the inputs, and then plug the inputs into the predictor, and then return the value. And this is, here I'm not like this one doesn't have a return value, but here I'm returning straight from the function. That's a fine thing. You don't need to name this variable and then return the named variable. Sometimes I see it, but that's obsolete. Yeah. It's quite obvious what it does. So. Mm-hmm. And then here I can start deleting more. Obviously I can remove again all of this. Right, I'm training the data, and then the Y estimation is okay, I'm a bit lost. What's happening here? Trains test. So under the split, I'm immediately having this. I'm training the model, and then I'm having a Y train estimation. Yes, so immediately estimate. And then I'm running the confusion matrix of this. But yes, this is what's happening here. So I don't have this variable anymore, so I'm just going to inline it. It's perfectly fine. And the testing phase, we don't need any of this. The only thing we need to keep is this, right? And we don't need to keep this. Because essentially what we do is this one takes train passengers. So the train estimation is coming from the train passengers through the predict interface, right? We calculate the confusion matrix, but now we need to extract the variables here because that variable doesn't exist anymore.
Yep.
With the second one, again, so I'm going to write the test passengers here. And then immediately go into the testing, because obviously now it's a much cleaner structure, because essentially what we are doing, we are getting the passenger data, we're splitting these passengers into two sets based on this strategy. We are creating a model, train it on one set, predict what will going to be the output. If you want to, you can move this into the train function, but sometimes you can train a model and you don't need the training estimations because that's not too useful. And then immediately you call the confusion matrix, and then the same thing happens with the. Then here you need to rename this because this doesn't exist anymore. This is a test passengers. All right, so this should run, and then the only thing what I want to do is, obviously this is a bit weird what we are doing, and again here in a real environment I would think of how to test this, right? How can I make sure that I don't need to recreate these variables? But here we are essentially calling the model output again. I would write new tests here and find some better things to check, right? Because it's essentially you need to check things that are actually named or created here. I'm going to run it and then see what
but you also need to really check the steps, right? Just so that you know if something fails, you know where it failed, right?
Yep, because what's going wrong? Predict train passengers. Maybe I failed twice.
Are you using estimate instead of predict?
Yep. That's the wrong function. Yep. Yeah, that's why we have
It's not pre-processing.
Yeah.
That's
all right, and now it's a bit off. And it was the test. Why was it the test? Yes, because here again, copy-paste coding.
Yeah, this can get a little bit.
Yeah, tricky. I mean, but it tells me, one of them is 1,000, another one is 260, and I know what the percentage is, so I know immediately it's 20%. So I immediately know that I must have mixed some test and train numbers.
Yeah.
You can have more, like here it doesn't tell you anything, but you can have like visual indicators that nothing happened, right? Tell me, it's one thing that the test passed, but if I swap both the in truth and the other one, I might be accidentally unaware that some change happened, right?
Yeah.
Okay, and this was working, so. Right.
Yeah, and you can really write these test functions like the way you prefer, right? You can start checking columns
or have multiple versions of them.
Vector. Yeah.
Because obviously you can have anything you want. Like this is like the simplest version. How many diff you want, give any kind of indication that you are still in a state that.
Yep.
But these are not for statistical analysis, so you don't fail the test
Right.
because you don't train the model correctly or you didn't use a feature test, because that's an analytical problem. That's not an engineering problem. What's a good model? Here, if you have one row less, the only reason it can happen is something broke. Right? If something like an F1 score is off by 10%, what does it mean? It's like your model differently.
We're actually testing the code. Yeah, we need to.
Yeah. And this is usually there is like a test cascade where it means that my code, this one is running like this fast. It's like anytime willy-nilly I can run it. But for example, every day I run a large test, which let's say take an hour or 2 hours. When I'm consuming an entire data set, I save a lot of special information, calculate diffs to the previous runs, and then analytically analyze it the next day. Cool. So that was running as well. And we are in step 20. So what's happening here? Obviously, we are at the bottom of this testing. Now, the only thing left is this test, right? Refactor. Because obviously, this is like your production code. So you can't ship your tests, all right? You can have observability situations where these are emitting some kind of information of what kind of state you are, but these tests are really only for refactoring. But at the same time, I would like to keep them as they are, because I'm going to refactor this code while it is in production as well. And this is one of the key aspects of like experimental operational symmetry, is that at any given time when I'm running a test and making a change in the code, I expect the same thing happen in production as well, all right? So I'm not testing the code on my machine, I'm testing actually the code on the production system. And I need to maintain a state which is similar to what's happening there, on my own machine, all right? And there as well, it's like, okay, but you don't have a database on your local machine. Yes, but you're not testing you don't want to test the database itself, right? It's either there or not, or maybe the engineers will going to run tests whether that's there or not, right? You want to abstract that away, and you want to test the part of your code that is actually your business, right? So So essentially what we are going to do is, anyway, these models need to be saved anyway. So we are going to just create a model saver class, which is going to save some information about the models, and we create another model saver, which is called test model saver, which doesn't save models at all, right? So what does it do? It probably should be named better, but essentially, instead of saving the models, right, it's essentially running the tests, right? It's using the same information as you would have saved in the model, right? Yes, in the model, so you can cut this part, and we are
they have the same interface. It's important here.
Exactly, and these are again context dependent. So we need to pass these externally. So we inject these, right? Because in production, the model saver will be the actual model saver. But if you can think of this, if you want to save it into MLflow, replace this with an API call to an MLflow server, all right? So it means that the same save model, you send a model, some kind of like some kind of metadata, and then here, instead of pickling, you would have some kind of API call which uploads the model to the server. So you essentially solved a lot of problems. You don't even need to know how you are going to save it in the future, because maybe the MLOps stack is not ready when you are doing that. And I think this is, again, part of that clean architecture, is that decisions can be delayed as long as it's possible, until you need to make a decision. But because the longer you wait, the more information you are going to know to make the right decision, right? Cool. And I can going to replace this one with the actual cause.
Just out of curiosity, it just came to mind, but like experiment tracking, do you consider that as, it's probably part of the pipeline, right? The process is not really an output, right? So if you use MLflow just to track an experiment, then that could be like another class that you plug in and that just tracks like a model or something, right?
Is MLflow has any kind of business value, business relevance? That's not. You and I using the same MLflow, and our domains have nothing to do with each other. So it means that that's a clear sign that this is not a domain problem. If you think about the circles of the clean architecture, it's an external issue. Therefore, you need to decouple from it and then use an adapter to do that. And then it doesn't matter, because obviously you can have weights and biases or anything else you want to store these and the same for deployment. And obviously we are not dealing with every aspect of a MLOps stack, but this is how we think about that, is like it provides me some kind of service, so it has some kind of interface, but I don't actually know what it is. And I'm starting writing my code, because obviously you don't get it right, because some of them require different parameters, and then these kind of aspects, coherence, which means that where this parameter needs to appear in my code, like that's an important question as well, which is probably down the line somewhere, but these are interesting questions as well. And obviously once you did this, I'm just going to production. I'm going to use a real saver, which saves into files, right? But in the testing environment, I don't need these files, because it means nothing, because it's not going to save these. So I'm just going to use this, and then let's see if it's still running the tests. And it is still running the tests, right? And actually removed one test, because it's a bit cumbersome to do that, but it's fine. Cool. All right. And I think this is the last step, right? So what are we going to do? When you look at this code here in the refactored form, is pretty much very little thing going on, right? So you get the data, you run the splitting, you do the training, you do the testing, and then you save the model. So it has like a good workflow structure. You understand what is it. If you are concerned about how estimation works, you can just go there and then look at the code, or how to do training or anything like that. What I would like, but here there's still a major coupling, because the model itself is hard-coded into it. The only thing I can run is using this this logistic regression with the setup and with these parameters. All right. So this is what we are going to decouple at the right now. So essentially, I am going to get the model as an external service as well. Cool. And then here, instead of I'm going to remove this, because obviously the constructor we're going to create this, and because this doesn't exist anymore, the IDE tell me that I need to edit the code in some way. Obviously we know how to we need to edit it.
Yep.
All right, and here down we are going to add the model itself. How does this work? Let me look at this again. Okay, because here the logistic regression. Okay, let's do this in one go, and then we are finished. Right. So this one is actually in production. We are going to use the model as it is. Okay, so we are creating this model, but here we are plugging in. So we inject the model like a dependency into this training structure as well, and now we can figure out of what its parameters should be, and this one is a parameter to the imputer. But clearly, if I create a different model, let's say random forest, that will going to look differently here, and I can do that as well. It's going to run like this. Okay, so it gets unexpected neighbors. What can it be, right? Because I copy pasted the code, and it obviously has these variables, and then I go to a model and that was not prepared for this kind of, like, it doesn't have parameters. So what I'm going to do is, like, I'm looking at this one and, like, this is a magic number, you know, it's like, why 5, why not 10? All right, so I would like that to be an external parameter, and the other one is that the predictor is an external variable as well, because I expect that this is going to be something I change a lot, right? So these are not just arbitrary changes. You know, this would assume that I would like to use different model variables.
Part of experimenting, right?
Yeah. If this is fixed, you know, for example, your current state of experimentation is about feature engineering, that you are actually not swapping the predictors, you might as well leave it hard-coded and then figure it out later as an experiment.
But this brings actually an interesting point, that the way I like to think about this as well is, like, you're adding this to this Titanic model class, right? But what we're working with is mostly actually the sklearn API, right? In that model, it's all wrapped into that Titanic model. So you can kind of think of this as an sklearn model, right? But say that the problem changes and you're like, okay, I want to try some deep learning with PyTorch, right? And what you can do is you can create another class that's really similar, but since the API is different, maybe the pre-processing will be different. You won't be using sklearn. You won't be using the transformer imputer from sklearn, but rather you'll be using the PyTorch API, and you can just switch the models instantly, right?
Exactly. And then you can think it through of how to use as much of this code as possible, because maybe even if you use deep learning model, this part is going to be the same, or maybe this is not fast enough, and then you need to write some kind of different structure here that more efficient. So there are, like, a lot of questions around, like, efficiency and how to figure it out as you go along, because that's your biggest problem, is that you don't know. Most of the answer is that you need to start working, and hopefully at a quality that you can like maintain, and then kind of
freedom to switch, right?
But you also, if you do something once, you would like to do it well, and then you can forget about it. All right, and this is a good state to be, because you only ever need to go back to it when you actually want to change it. Right, and this is an important exercise here, is that I would like to do good work early on that I can leverage later, right? While a lot of the components details I don't know. Like that's used to be the question, the answer in the Discord channel as well, is that start doing it, write your tests, run them, and then if you realize in the future that you need to change something, then you can do it.
Yeah.
Cool. Okay. Anything else?
No, I mean, just. No, I think this was really important. Like the first time I stumbled, you shared this exercise with me. It was really important just to learn those basic steps. And so I'm just to testify that now I'm kind of building upon, this knowledge. So then you can start exploring other things now. I think this is really interesting now. It depends. Maybe you're more interested in the data science side as opposed to the programming side, but I think these are really important basic blocks. But then you can start exploring things like type hinting, which is something that I generally like, but that's just, depends on what you prefer, right? Or your styles of writing code and everything. But I think this really got me started into this way of thinking about how to organize these projects.
And what I found important is that you kind of like think in code, like you are making, like I'm trying to figure, like if I have an idea, I try to write it down immediately to code, and then structure your project in a way that if I have an idea, I can just write that and then set up an experiment and then run that. And then if it doesn't work, I can switch back. And also often you open a branch and then refactor something of maybe this is better this way. All right. So like the code is a bit cleaner, it's like I can understand what it does in more succinctly. And then problems get to the right place, so I can imagine that I can solve different problems in the future, and that's a very important workflow, because you keep running the test and then you get used to committing into Glitch or pull requests and all of these components of these SSL, and these are just routine, and then you immediately start you're not fighting your code base anymore. You are thinking about it as an asset, like how can I reuse this? It's like how can I change it in a way that it is even works for me? And then you start like growing faster, because otherwise notebooks are often, you do that, but then they get into a state where you don't really want to touch it, and then you don't really want to know about it, because you know that it's not really reusable, right? And this is what I found, that this is better in this structure. Cool.
Yeah,
All right.
absolutely.
I think it was 1 hour and 45 minutes. I think that's definitely faster than before. And I think like there was a lot of copy paste coding. I think that it's still an important way of using this, is that you are copying from the pull request into the structure, and then try to understand why is it happening, and get used to this kind of practice of writing classes, thinking about interfaces, moving code around, renaming, for example.
Yeah.
And cool. I think this was very good. I hope the recording is better than last time. I'm going to go and check it right now and share it with the community.
Okay.
And thank you very much for your help on a Sunday afternoon. It's highly appreciated. And I would like to thank everyone who's survived this long. And I hope it's going to help you a
Thanks for
lot with
watching.
your work.